previous lesson, we looked at Perl data types. In this lesson, we're going to see how we use those data types in programming Perl. Let's take a look at a few Perl-specific commands. The first thing is how we actually add and remove things from an array. There are 4 commands that we need to know: push, pop, shift, and unshift. And they do opposing things. Let's take a look using Perl. So here I have an array. I'm going to call my array at A, and I'm going to have 3 numbers in my array, 5, 6, and 7. And I can say print at A and a new line. When I print the array like that, Perl automatically adds spaces. What I've done is I put my array in double quotes. That tells Perl, add some spaces to the array. Now I'm going to try my 4 commands: push, pop, shift, and unshift. First of all, let's push a number onto the array, and we're going to capture the result. The result of push onto my array A, the number 1. When I say print at A /n and $C/n, this is going to print first of all the array and then the result of pushing that onto the array. So you can see that I've added the number 1 to the end of my array. I've pushed that number on, and I get returned the total number of elements in the array. So that's push. Push adds to the end. Let's try pop. What happens if I say pop from at A, and I'm going to print my array and the value that's returned? What do you think it's going to be? With pop, I remove the value from the end and it gets returned. My array is now only 5 and 6, and I get the number 7 returned to my variable C. So push and pop work on the right-hand side of an array. The corollary to those is shift and unshift. I'm going to say shift from my array a value and print out the array and the value that's returned. Now my array is 6 and 7 and the value 5 is returned. So shift removes something from the beginning of an array. And then the last one is unshift. And unshift is like push. It actually adds something to the array, and that of course adds at the beginning of the array and returns the number of elements in the new array. So I've got push and pop working on the right hand side of the array, shift and unshift working on the left hand side of the array. In addition, I have 2 special arrays which are at argv and at underscore. You're going to see those come up when we start looking at more detailed programs. Let's change tacks a little bit and talk about truth for a second. So if something's not defined, it's not true. And 0 is not defined. So what that means is that 0 is not true. If I have something where the value is 0 and I say if this thing is true, like if $A, else do something else, if $A is 0, that's not true, that command won't complete. 1 is defined, 1 is true. 0.01 is defined, 0.01 is true. So I have standard constructs: if, else, if, else. And then I have a command that's pretty much unique to Perl, which is unless. So unless $A is greater than 1, do something. So it's kind of like if not. So if $A is greater than 1, do this. Unless $A is greater than 1, do this. Similar kinds of statements. I have while and until statements that operate just as you would expect. $A equals 0, while $A is less than 10, keep adding to $A. $A is equal to 0 until $A is greater than 10. Keep adding to 0. So while and until. And then there are two commands, for and for each, that iterate over ranges of numbers. So for example, for, in a very standard construct, just like you'd see in other languages, for x equal to 0, x is less than 10, add 1 to x, do that loop. The for each construct is somewhat unique, which is for each $x in an array. Let's take a look at that and see how that works. For each, oops, excuse me, I need to type some Perl here. Perl minus E. For each $x in 1, 2, 3, 4, 5, print, oh my goodness, print $x, and we'll see what happens. It just iterates through every element in that list. So that's kind of like an iterator. In addition to iterating over each element in an array, using for each like this, we can replace the list of elements with just the name of an array. So we can say for each $x in an array, do something. It's the same notation. We can join arrays and split strings using the join and split commands. These are functions that we call, and we provide arguments with them. Notice that Perl is not an object-oriented program. These functions are not a property of the string itself. They're just functions that we call. So for example, we can split a string based on white space by just passing the split function the white space and the string to split. That will return a list of the words. Or we can split on a new line. We can take a list, an array that we have, and we can join it using either spaces or using tabs, for example, and print out the result. So split and join. They do pretty much what you'd expect. Let's take a look at file handles. So open and close. We use open to open files, close to close files, pretty obviously. And the open command takes 3 arguments. The first, usually abbreviated something like FH or IN, is a file handle that we're going to use subsequently. The second is a direction. In this case, it means open this file for reading. And of course, we have reading, writing, and appending, and I'll show you the 3 notations for those in just a second. And then the third argument is the file name that we actually want to open. So we have open, a file handle, a direction, and the file name. When we're finished with the file handle, we can close it. That closes the stream so that we can do other things. So a less than sign means open for reading, a greater than sign means open for writing, and 2 greater than signs mean open for appending. This is something that's kind of been inherited from shell scripts, where redirection in shell uses greater than and less than signs in exactly the same notation. It's a very common notation that you should get used to. So you can pass the open command 3 parameters like this, but this is Perl that we're talking about. And one of the things that I told you about Perl is that the motto is there's more than one way to do it. I pretty much have just shown you one way to do everything so far. So let's look at a different way. We can pass 3 arguments to the open function. We can pass the file handle, the direction for opening the file, in this case reading, writing, or appending. Or we can pass in a 2-argument open function, where we pass in the file handle and we pass in the file name prepended with the direction indicator, either open for reading, open for writing, or open for appending. Because it's Perl and programmers are lazy, most often we want to open a file for reading. And so there's actually a simplified 2-argument version where we just pass a file handle and a file name. And by default, Perl will try and open this for reading if the file exists. There are equivalent 3 and 2-argument open functions for writing, as I've shown here. When we open a file, it's really important that we want to know, did the file open? Was that successful? If we have a whole bunch of data to write, we don't want to start writing our data out until we're sure we've got an open file handle. And open file handle file name returns true if it's successful. And so one of the most common ways of opening a file is to use this structure that's shown here. We open the file handle for a file name, and if that's not true, we die with the command can't open file name. Die means stop right now. It means die. It doesn't mean finish what you're doing and then gracefully exit. It means get the hell out of there. And so Perl will get to this point. If it can't open this file, it dies immediately and says, I can't open that file. I don't know how to proceed. Notice here we have an OR construct. This means do the thing on the left. If that's successful, carry on. If that's not successful, do this other thing on the right-hand side. So open the file. If the file is successful, we've got true, so we carry on. If we don't successfully open the file, we want to do the other thing, and the other thing is die and get out of there. So how do we use file handles in Perl programming? Let's take a look. So here's a little bit more complicated construct. We open our file handle with our file name, and if that doesn't open, we die and we say that we can't open the file name. And now we have a while. While this file handle is true, we do something with the file. When we get to an end of file, this reading the file handle becomes false. At the end of the file, that's false. We stop doing the while loop and we get out of there. Once we're out of there, we've read the whole file, and so now we can just close the file handle and carry on with the rest of our program. Most often when you read a text file, the text file ends in a new line. And the first thing you want to do is remove that new line from the line that you've just read. The way that we do that in Perl is with one of 2 commands. The first command that was introduced very early on is chop. And chop just removes the last character from a string. It'll take whatever the last character is, it removes it and returns it. In Perl 5, a new command was introduced called chomp. And chomp removes the last character if and only if that last character is a new line. So most often what we want to do is we want to read a line from a file, we want to take that last character, if it's a new line, remove it, and then carry on with the line. Notice in Perl that strings are mutable, so we can change that string. When I say chomp $string, it changes the value of $string. I don't have to return that to a new variable. I've already discussed special variables in Perl, and there's an extra special variable that Perl programmers use all the time, and it's called $_. $_ is used whenever you don't provide a variable for Perl to use. And let me demonstrate what I mean with this simple piece of code. So here we have some code where we open a file, we read a line, so while $line is equal to in, we're going to do this loop. So the first thing we do is we remove the new line. We take that line and we split it on tabs. Remember, /t means a tab. That returns that new line into an array called @values. Now, for every value in the array, we sum those values together. And then finally, we print the sum of that line. And then lastly, we close the file. Let's take a look at this piece of code in action. So in my terminal, I have a file called data.txt. And data.txt, as you can see, just has some tab-separated numbers. So I'm going to write my Perl code as we've just seen it, and it's going to be called sum.pl. So I'm going to take a file, and I'm going to say my file is called data.txt. And I'm going to open the file name. And if it doesn't open, I'm going to die and say can't open $file name. That will tell me that I haven't been able to open this file. While I read a line from this file, I remove the last character of that line if and only if it's a new line. Remember that changes the string. It's a mutable string. Now I'm going to split that line based on tab characters. So now each element of @values is a different number. And I'm going to sum up all of the values. So I told you about for each $value in @values. That means let's iterate through this array, putting each element in $value. $sum is equal to $sum plus $value. And then for each line, I'm going to print out the sum of the line, $sum/n. And then finally, I'm going to close my file handle. When I run this command, it prints out the sums of those numbers in my data file. Okay. Just like I've shown here. However, I can use special variables, the $_ variable, when I don't want to provide a variable name, if I want to be lazy. So let's start by getting rid of the $line variable, that scalar. We don't care about that scalar. We can get rid of it. And the way that we get rid of it is we just say, we're not going to tell you what this variable is going to be called. We're just going to leave the variable name blank. When we do that, Perl says, I don't have a variable to put this scalar into. I'm going to put it into the special scalar $_. So in the first line, we put what we've read from the file into $_. Here we call chomp, but we don't say chomp a string. We say chomp on some unknown variable. Perl will automatically work on $_. And then when we call the split, we don't give a variable to work on, and so those numbers get put into, the split operates on $_. If I run that piece of code, I get exactly the same result as before. $_ is a special variable that allows me to remove several of my variables. So one way I can reduce the code is by using $_. Another way that I can reduce the code is by using the map command. Map works on every element in a for each, and it applies that element to $_, that special variable. However, it's a different $_ than the previous one. So we can say map, do something to every element in our array. So for example, we can change our code, and instead of saying for each $value in @values, we can get rid of this line. We can say map $sum is equal to $sum plus $_ in @values. Now when we sum up, we get the same answer. So our code has gotten a lot simpler. We've removed one whole loop where we're iterating through and written that as just one single line of code. We can get rid of those 3 lines and we can replace them with 1 line of code. And that's the code I just showed you. However, we've got an array that we create here, and we use it immediately on the next line. And so, in fact, what we can do is get rid of this declaration where we declare an array and this line where we use that array and join those together into one line. We can just say, apply the map function to the output of the split. So when we go back to our piece of code, we can apply the map function to the output of our split. Here's our split command, and there we go. We've applied the map function to the output of the split. When I run this piece of code, I get the same output as before. So now we've reduced our code from about a dozen lines down to just a few lines. How can we make it better? It turns out that if you're going to iterate through something, we can actually do that on the command line. I've already shown you the Perl -e syntax. I used it to sum up 2 numbers. I had, on my command line, I had something like Perl -e $A is equal to 2 and $B is equal to 3, and then print $A plus $B. And it prints 5. Perl -e means execute some code. We can actually extend that using what's called lane. So Perl -L means chomp the lines on the input. Perl -A means take the first line and split on white space. Put that data into a special variable called @f, an array @f. And the f is supposed to remind you of fields. -n means process every line in the file. And -e means execute that code. And so we can take our code and we can change, instead of having a file where we have a script that we edit the code, we write in the code, we run the script, we can have a 1-line piece of Perl code. And so I can copy this piece of Perl code right here, and I can paste it into my terminal window, and I can iterate through the file in one line, and I can print out all the